All righty. Hope you all are doing great. I'm starting to get sick again. I looked over. Everybody got the first practice assignment? I looked over it and tried them myself, and the first thing that came to my mind is that if you recurse only once, if you only have one friend, then to me, why aren't you doing it iteratively? But that sometimes happens. And the other thing that I told you very strongly about last class was never write a program that takes exponential time. And we haven't really talked about how to evaluate the running time of an algorithm. So maybe you wouldn't worry about that anyway. But the one problem that's there is actually NP complete, which means that there's no polytime algorithm for it. So don't try. And another one, I couldn't think of a way to do it in polytime and recursive, right? So using dynamic programming, which you won't do until 3101, you can do it in polytime, but you're not expected to do that. So you're expected to come up with a recursive program that takes exponential time. I had some other thoughts about some of the assumptions that Jackie made as the precondition. He said, assume this and assume this. And he hasn't really studied my complaints, and maybe he will take them on and maybe he won't. But as a general rule, if I want nice, clean, recursive code without a lot of if statements, sometimes I don't want to be checking whether the precondition that he said is true. I just want to go for it. And that means then you'll recurse on examples that don't meet the precondition. And that's okay too, if it makes the code nicer, right? If it's not wrong to give good answers when the precondition's not met, right? When his preconditions are not met, you don't need to do something good. But if it makes your recursive code cleaner, then there's no harm in doing it, right? Any other thoughts? All right. So, does anybody know when it's due? Oh, gee, not for a long time. All right, so good. We'll have a lot of time to think about it. So, if you didn't catch our pattern, there's the table in which which I'm planning on doing things, and our plan is just to do one slide at a time through those. So if you ever want to know what we're doing next, we're doing the next slide. Now, what place that we broke that pattern is last class. We jumped ahead to recursion for this assignment. So now we're just jumping back. And when we get to the recursive topic, we will try to remember what page we were on and jump back in, unless people want to review it again. Everybody good? Any thoughts? All right, so what we're doing now is pointers. And I taught in Africa for a year, and I made these slides in Africa because the students there particularly, well, maybe it's because I don't usually do coding courses, right? But they had such a hard time with pointers. I mean, you just wouldn't believe it. And my sense is people have a hard time with pointers. And the secret to handling pointers is, one, be careful about what type everything is, right? There's a difference between being an elephant and being a pointer to an elephant, and being a pointer to a pointer to a pointer to elephant, right? Those are all different. That's the one thing. And the other thing is you draw little pictures with arrows, circles and arrows. And oh, and the other thing is, to think about x equals y. What does that mean? That means y is a box, and you take the value out of y, and x is a box, and you put the value into y, right? So, I mean, the things I'm saying here is obvious. And it's good when it gets more complicated to be sure about what's happening. All right? So, last class, no, the class before, when we were doing abstract data types, what I had gotten from the book I was supposed to teach from was this idea of positions, right? So that's kind of an abstract concept of he's a person, and my job could be storing where he's sitting, right? So I would be a pointer. So that's what these pictures here is, right? This cell here doesn't store a value in itself. It stores the address of this memory, right? And they were abstracting that as a position. And I don't know whether that's useful to anybody or not, or we could just call it a pointer. It's a pointer, right? All right. So this is what I just said a minute ago. What does this code do? P, what is P? It's a variable that has a block in memory allocated with the name, right? And we put the value P in it. And I think I said this already in class, is there's a difference between what happens when compile time. I know how many variables have names, right? There's a fixed number of variable names. And runtime, Turing knew that you needed the amount of input, the amount of memory you use needs to grow with the size of the input, right? So you need more memory than there are names for memory, right? And so you either need an infinite tape with the head moving back and forth, or you need pointers, right? And so this P is the variable that at compile time was allocated in the stack frame of this routine to have a name, the name P, and it's ready to put something in, right? And if it's a typed language, like Java is, then it has a particular amount of bits because it's ready to store only one thing. And if it's not like Python, then it can change its objects. All right, so here, I mean, this is really, wipe on, wipe off. You know that movie? You have to, yeah? The Karate Kid, and I watched the version, and there's a new version for you, right? Simple things, there's deep meaning there, right? So what I'm showing you here is not, what this code does, but we're building up our how to draw these pictures and know what's really happening, right? So this is, my father will tell you, this is not a math statement. This is not saying P and Q are objects that have the same value. It's an action, right? And the action is to find the value referred to by P and put it in the box referred to by Q, right? So P names a box and Q names a box, and we take the value out of the box named by P and put it into the Q. And I keep saying this because, we're going to have variables that are pointing to things which are pointing to things. And so you have to think, where's the number coming out of and where is it going into, right? It gets more complicated, right? Just trust me. All right, we do this, then the 6 gets overwritten, pretty straightforward. We say print P, and 5 gets printed. Everybody's happy, right? That was easy. All right, so now P is not in Java, the only things that are actual objects, I think, are integers and reals and things, right? If it's anything more complex, then the exact same code doesn't work the same, right? Here, now, Java says that nothing is a pointer, right? But really everything's a pointer. What's P? Is P this record, or is P a pointer to this record, right? It gets confusing. And all right, so then I say Q equals P, and now you have to ask what happens, all right? And you might think that what happens is that big data structure gets copied into Q, right? Anybody think that? Because if you think it, you're wrong, right? It's not what happens. What happens is pointers, right? All right, so here, this is actually the name of one of the schools in Africa. That's why it's there. We say q.work, right? And so what does this do? It says q is a record, work is a field within that record. I'm going to go to the little box work within q, and that's going to be my work field, and I'm going to change it to where I am. I'm no longer at York. I don't forget what Hearst, I don't know, someplace in Africa. All right, everybody get that? And now I say print p.work, right? And what does it say? Everybody, how many people think it says York? How many people know it says Hearst, right? Right? Everybody follow, right? All right, so you guys might know this stuff already. Did we really want to copy this? No, that's too much work, too much time, too much memory, right? If you want to copy it, you got to do it yourself. Really, right? Right? They don't contain the same data, right? They are the same data, right? And I personally find, if you think about Java as having no pointers but being objects, this just gets more confusing than realizing that it's a pointer, right? I mean, we're going to get into this later, but linked lists, my link contains other links. Well, is it in there? No, it's not in there. It's a pointer to there, right? I mean, it's just absurd. All right, so just like Jeff and Edmonds are the same, the name for the same person, same as P and Q, right? So we put it in there, and when we print P, we get, right? So how is this implemented? It's implemented with pointers, all right? So what is the type of P, right? P could be an integer, or it could be a record, right? It could be a record in memory with the name P, but it's not, right? That's not how it's implemented. It's implemented, P is just one little box that stores one little integer. And what is that integer? It's the address of the memory, of the block of memory somewhere else, right? Right, and so how is this implemented? It points at the data. It contains the address of the data. So this data is stored somewhere in actual physical memory. And actual physical memory has an actual address, right? Which is an integer. And that integer gets stored in this box, right? All right, so Q is also a pointer, right? So I think we kind of brought that up in class at one point. I sort of said, right, we declare here Q to be of type pointer to data, well, it's just a little box, right? We haven't actually allocated any memory for the data yet, right? So there, Q's a little box. There's no data associated with Q, right? And so we do this, and what do? We take the value that's in P, and we copy it into Q, right? And what does that mean? It means that they're both pointing at the same data, right? Everybody good? And all right, so now when we do this, what do is when we see q.work, we go to Q, we say, oh, Q's pointing at something. We go to where it's pointing. We say where we're pointing has a work field. In fact, it's offset by a little bit. So in fact, if the work field is, say, 20 bytes over from the beginning of the thing, then really what we do is we take 2039 and we add that offset, which gives us the address of work, right? That's what, if you do C is all about this manipulating addresses, right? So that's the big difference between C and Java, is C embraces and loves pointers. And if you have a pointer Q and you add 1 to it, in fact, not only does it doesn't move to the next byte, it moves to the next, it says, I'm pointing at something this big, and it moves that much further. It moves past what you're pointing at, right? So C really embraces this pointer math. And it lets you really get down, right? So in some ways, C's kind of really close to being a machine code, right? Because you really can get in there and play with the real hardware, while Java hides all that, right? All right, so we change that. And then when we go here, we go P work, and we get something different, right? Right, everybody kind of follow that? We get the, okay. Right, so this is kind of, I said this already, right? P is pointing at this whole data structure. The whole data structure is stored in some big block of memory, and P is the address of the first guy. And when you say P.work, it's kind of like the address that's stored in P plus work is some offset. Right? It's kind of like adding that offset, which gets you into the field, right? All right, so what do we do with linked lists is the way we get more and more memory is you have things point to things, which point to things, which point to things, right? So temp is pointing to a record, which is pointing at a record, right? And head is pointing at a record, which is pointing at kind of, it's pointing specifically at null. It says, I'm pointing at nothing, right? So what's probably is actually stored in there is the value 0. And 0 means that I'm not pointing at anything, right? All right, so X and Y. All right, so here we're just kind of, right? So it's good to pay attention to, right, the names of variables and what's the name of this box versus what's contained in the box, right? Those are two different things, right? P is the name of this box. Here, X is the name of the box, and 2039 is the contents, right? So here, the name of the box, the location of the box is there, right? Whatever memory that box is, that's the location of the box. And what's the value of the box? That's the value inside, right? Everybody got that? Same with Y, right? If we do this, then you see I made the X red and the Y green just for symbols here, right? We're going from the green to the red, right? So we circle the box named by Y, right? And we circle the box, right? Green for go, I guess, right? I don't know what that means, right? And we circle the box named by red, and we take the value out of the red box, out of the green box, and we put it into the red box, right? Does that make sense? And you might think that what I'm saying is obvious, but, you know, over here, we're trying to figure out what's the value in the box, right? And over here, we're trying to say, what is the box in which I put the value? And you say that that's obvious, but it's harder when there's a pointer pointing to something, right? What's the name versus the values get much more muddled, right? Values and names of boxes are all muddled. So you just got to be more careful. That's all I'm saying, right? So you take the value out of the green box and put it into the location of the red box, right? Everybody good? Are we going too fast or is this too boring? And you know, I really honestly struggle with, am I boring you so I should go fast? Or I'm losing you so I should go slower? I think you're getting ahead. Let's work on the current slide. All right? Everybody good? Here, how many vote for slower? How many feel we're doing okay? All right, good. Good. All right. So head, right, there's head up there, right? The location, that's the location of the variable head. What's the value in head, right? Well, you could say the value in head is the value 2039. But what is that? That's the location of the record, right? That's why we don't really care about 2039. We really care about where we're going, right? So the value in the box is that record, right? And then, okay, now let's do head.next, right? What's the location of head.next? Well, it's that little field next, right? Head dot means go to where head is pointing. And you go to the record that you're pointing at. And then dot next means find the next box, right? So what's the location of the box talked about by head.next, right? It's that next box up there, right? And what is its value, right? Its value is 0, right? Okay, you know we're going to do this. Temp.next is here, and its value is here, right? So what we're going to do is we're doing head.next equals temp.next, right? And some of you can just know how to do this, but let's review it, right? Let's say temp.next, where's the box? That's the box of temp.next, right? And that's the value, that's the box for head.next, right? So what do? Is we take the value in the green box, right? What is the value in the green box, right? It's that next record, right? So you take the value in the green dot box, which is that record, and you put it in the red box, right? So what changes, right, is that red box is now pointing at the record, right? People follow that? How many people was this obvious? And did anybody find this useful? A little bit, maybe, maybe not. A little bit useful, all right? I mean, the truth is the guys in Africa were probably behind you, right? So positions, given the data structure, we want more, lots of, right? Right, so this is just what we had before, right? We have concepts of what positions mean and moving them about. And any questions about this? We did this before, yeah? Sorry, what? Yeah. So head.next is referring to this box, and currently it contains 0, right? Hmm? The value in head. Yeah, this is the address of this memory. And right, so we have a row of memory, and we look at the cell labeled 2039, and that's the value that is stored in the element box. We go 1 over, it's the value stored in the next box, and currently the value is 0. And why is it 0? That's how we arrived. That's the value before we execute this code. Yeah, the value in temp.next is 9321. Yeah, exactly. But I'm drawing it as, what is 9321? It's the address of this box, right? So that's why I'm pointing there, right? Right. Should we go over all any of this? All right, so we can store them in an array. All right, we can store them in an element, right? So each of these is linking to the next, right? I think you know this already.